We want to work through one more example of quadratic modeling that is a little bit different than the two we've seen already. In the previous two, we were given our function. Here, we're given data in which we'll have to use to find a function. It says this: the data below shows the average monthly temperatures of Salem, Oregon for January through May, where January we're calling month 1 and May obviously is month 5. So you can see this in the table in regards to the months here represented as numbers so that we can work with them, and then temperatures in Fahrenheit, the average temperature in that month. So the question is this: as we start off, what is the independent variable and what is the dependent variable? One way to determine this is to ask yourself, is the temperature dependent upon what month it is? In other words, does the temperature change as you go from month to month, or does the month change as you go from temperature to temperature? In other words, is the month dependent upon what temperature it decides to be? Well, no, the month happens no matter what the temperature is, so we would say that the temperature is dependent upon what month it is. Therefore, our independent variable will be month, or months, and our dependent variable will be temperature in degrees Fahrenheit, because temperature is dependent upon what month it is. But here's how we're going to find our model. It says this in part C: use the quadratic regression command on your calculator. Using it, find a quadratic model where T of X is temperature in Fahrenheit and X is month. Let's go ahead and put X here for month and T for temperature now that we have our variables identified. So we want to go ahead and use the quadratic regression on our calculator. So let's get our calculator up here. Now, to do quadratic regression or any type of regression on our TI calculator, we first need to go to Stat. So we hit our Stat button, and the first options that are selected are Edit, Edit, and that's where we want to go, because it'll take us to our L1, L2 columns where we can fill in our data into the calculator. So L1, we want to be our independent variable. Well, over here we have identified months as independent variables. So what I'm going to do is I'm going to go ahead and type in 1, enter, 2, enter, 3, 4, and 5, because those are my independent variables representing months: January, February, March, April, and May. I'm going to hit my right arrow to go to column L2. L2 is where the corresponding dependent data points go. In this case, dependent is our temperature in degrees Fahrenheit. So I'm going to start by putting in 40. Next is 53, 64, 72, and 77. So we have our data in our calculator now. Now we want our calculator to do a calculation with it. So we're going to go back and hit our Stat button again. But this time we're going to go hit our right arrow over to the Calc menu. Several options in here. The option that we're going to select is option number 5 that says Quad Reg. That stands for quadratic regression. With option 5 highlighted, hit enter. It correctly identifies our X list as L1 or Y list as L2. That's independent and dependent. And the frequency list and next option, the store regression equation, don't matter to us at this point. So we're just going to scroll down to calculate and hit enter. And as it does that, notice we have y equals ax squared plus bx plus c. And it gives us the value of a, b, and c. So it's telling us that the value of a is negative 1.36. So a is equal to negative 1.36. Our value of b is 17.44. And lastly, our value of c is 23.8. So it's telling us our three coefficients for our quadratic model. We know our quadratic model in standard form is y equals ax squared plus bx plus c. For us, though, we know our dependent variable is t, so it's going to be t of x is equal to a. We have identified a as negative 1.36 from our quadratic regression, and that's x squared, plus our b value, which is 17.44 times x, plus c, which is 23.8. So from the quadratic regression in our calculator, here is our model. So we can now use this model to make calculations, to make estimates and predictions. Let's take a look at this first one. It says this: what is the estimated temperature in November according to this model? Well, in November, what data does that actually give us? Well, first let's identify what they're asking us for. They're asking us for temperature, and they're giving us the month, November. The question is, November gives us what? Well, the month is our x variable, so November gives us that x equals, well, if January was 1, February was 2, if we keep counting and get to November, we find that x is equal to 11. So we're given that x is equal to 11, and we're supposed to find our temperature. So using our model, it's asking us to find T of 11, the temperature when x equals 11. Well, that equals for us negative 1.36 times 11 squared plus 17.44 times 11 plus 23.8. So we plugged 11 into our independent variable x, and now we simply simplify the right-hand side of this equation to find the temperature in November. So that's negative 1.36 times 11 squared plus 17.44 times 11 plus 23.8. Hit enter and we get a 51.08. So we are getting that the temperature in November is 51.08 on average degrees Fahrenheit according to our model. Great.